So guys, today we are going to deal with a chapter called as Haloalkanes and Haloarenes. That is, we are going to deal under the branch of chemistry called as your organic chemistry. Yes, so under this branch of chemistry we are going to deal with a chapter called as Haloalkanes and Haloarenes. So before starting with this chapter, I would like to remind you one of the most important things one has to know whenever you're going through with your organic chemistry part. First and the foremost thing, whenever we are dealing with the organic chemistry, you should first make yourself understand that how to write the nomenclature. First important thing, nomenclature of any given organic compound. What are the steps involved in it is the first criteria. We have to know it. The second most important thing is, of course, in your exams and also in your competitive exams, whatever the named reactions, I repeat, whatever the named reactions which is going to come in this chapter are very much important. You have to make a separate note of those named reactions. What are the conditions we have maintained in it? And the most important thing is to understand a reaction through its mechanism. Of course, we are going to see certain mechanisms also over here. So these are three important things one has to make yourself well equipped with your brain, that you should know how to write the nomenclature. You should make a separate note, even though you can make in your mind or in a separate notebook, or within the notebook itself you can leave a page for a particular chapter, and at the last, after the ending of the chapter, write all the named reactions, so that once you can open that page, each and everything of the reactions will be recollected. And the most important thing is to know the mechanism. That is, when I am writing a reactant, I am getting a product, how that reaction is proceeding to give you that particular product. So these are the important criteria one has to know whenever we are dealing with your organic chemistry. Because it will be quite a different scenario when compared to that of your physical and inorganic chemistry. That is the reason I am reminding you before starting my concept under your organic chemistry. So coming to the chapter, we are going to deal a chapter called as your Haloalkanes and Haloarenes. Of course, I think you have got a hint what we are going to study in this chapter. Alva, very good of that. So basically we are going to study your aliphatic and your aromatic structures which is been attached to that of your halogen group. Once again I repeat, so we are going to understand the concept, or we are going to study the compounds in which your halogen group is attached to that of your aliphatic, aromatic and alicyclic systems. Very much important. So first and the foremost thing, we have to understand generally how does this structures look. Basically, most important thing, if I am going to write as a methane, how can I write? Yes, CH4. So when I consider this one as a methane, in case if I have to write its haloalkane, how will I do it? Of course, I could remove one hydrogen. I will be adding my Cl. I can remove another hydrogen. I can add two Cls. So like this, even I can remove one more hydrogen and I can add three Cls. Similarly, I can remove all the hydrogens and I can add all the Cl over here. So these are the examples. A general, quite a good example we can say of your haloalkanes. Alright, since we are taking an alkane. Haloarene, of course, this is your benzene ring. When I take it as a C6H6, if I am going to remove one hydrogen and if I am going to write as my Cl over here, of course it is an example of your haloarene. So what is the general thing we are seeing? Of course, till now we have seen many organic structures, but what is the main criteria we are going to study over here is, so in our structure, one halogen group will be attached to that of your minimum. I'm just saying one minimum halogen group will be attached to that of your carbon atom. So this is the major criteria what we are going to study in this chapter, their properties, what is their structure, how can we prepare it, and what are the important products we can extract from them. So coming to the chapter haloalkanes and haloarenes, first and the foremost thing we are going to study about their classification. How can we classify them? Classification of your haloalkanes and haloarenes, very much important. Remember guys, the first important classification we are going to study is the compound containing, yes, the compound containing your sp3-CX bond. What is that they are saying? The compound containing your sp3-CX bond, where your X could be your any halogen, fluorine, chlorine, bromine, iodine. These are your examples of your halogen. But the most important thing I would like to focus, what type of a hybridization I have written for my carbon atom. What it is? sp3. So what do you mean by sp3 hybridized carbon atom? The carbon atom which is attached to other groups through a single bond. Alva, the carbon atom which is attached to other carbon atom through a single bond. That is, for example, if I am going to write a CH4, how it is? C in this way. Is an sp3 hybridized carbon atom? Yes. Even though this one CH3, this is also attached to a single bond. So such carbon atoms are called as what? Your sp3 hybridized carbon atom. So first important classification, we are going to see our structure of haloalkanes and haloarenes, in which our halogen atom has been attached to that of your sp3 hybridized carbon atom. So under that first part, we are going to see under this classification, it is called as your alkyl halides. Alkyl halides, or they are also called as what? Haloalkanes. Haloalkanes. So first important classification we are going to see under your compounds containing sp3-CX bond is alkyl halides or haloalkanes. We know that whenever a group is lacking a hydrogen in your organic chemistry, for example, methane means CH4. When it is removed with one hydrogen, it will be given as a name as methyl. So when one hydrogen is missing, we will be adding it as YL at the last, alkyl group. Alva. So so to that alkyl group, we are also, when we are removing one hydrogen, in order to maintain our tetravalency of your carbon atom, instead of hydrogen which has been removed, we will be adding your halogen. So such structures will be called as what? Your alkyl halides or haloalkanes. So in actually here basically the halogen group, yes, is attached to alkyl group. For example, I will be just giving you. If I take it as a methane, CH4, alva, this is your methane. So in order to convert as a methyl chloride, what I am going to do? I am removing this one hydrogen, so I will be getting as a methyl CH3. So in order to balance my tetravalency, what will be having? Instead of hydrogen, I would be having my halogen. So such a structure is called as what? Your alkyl halides or haloalkanes. Can you see? Haloalkanes. Yes. But now the question arises, okay sir, then what about this compound containing sp3? You can only see it, alva. So whatever our X is attached, it is to our saturated carbon atom, which is further attached to a single bonds. That is the reason it comes under the compound containing your sp3-CX bond. So what could be its general formula? Alkanes and the bardaga and the barithi now CN H2N plus 2. This is for alkanes. Alkyl and the bardaga one hydrogen ategitini. So I will be getting as what? CN H2N plus 1. So instead of that one hydrogen which has been removed, what I am going to add? Add halogen. So what will be the general formula now? CN H2N plus 1 X. Alva. In case if I take this one as my example. So S20 C is 1. Hydrogen S22 1, 2, 3. Yes. ಅಥವಾ n is equals to 1 ಅಂದಾಗ CH3X ಅಲ್ವಾ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಬಂತ. ಸೊ n is important. ಕಾರ್ಬನ್ ಆಟಮ್ ಎಷ್ಟಿರುತ್ತೆ ಅದನ್ನ ನೀವು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ you will be getting one formula. So this is what general formula for your haloalkanes or alkyl halides. So basically this haloalkanes or alkyl halides are further classified into three important types. First one is called as that of your primary alkyl halide. Primary alkyl halide. That means what? Whatever our halogen group is attached, it is attached to that of your primary carbon atom. What it is saying? Whatever our halogen group will be attached, it will be attached to the carbon atom which is primary. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? CHHHX. This is also a primary alkyl halide. Or CRHH and an X. Then what is the thing we have to understand? What do you mean by a primary carbon atom? That means the carbon atom which is attached to only one carbon atom. The carbon atom which is attached to no other carbon atoms. Generally we will be not talking about this. We will be mainly focusing on this one. Of course this is also a primary, but generally whenever we are defining a primary carbon atom, we will be taking this one as an example, so that it will be easy for our understanding to distinguish from the other two classifications. So what do you call as a primary carbon atom? The carbon atom which is attached to another single carbon atom. Right? R and it could be R, can be anything. R can be your alkyl group or your ethene group, CH3. So it can proceed in this way. But what is happening in that? R one carbon atom will be present. Alva. So the carbon atom which is attached to another carbon atom, another one carbon atom. So such carbon atom will be called as what? Primary carbon atom. So to that carbon atom, if our halogen group is attached, it is called as what? Primary alkyl halide. The second important thing under your haloalkenes is called as your secondary alkyl halide. Secondary alkyl halide. So can you give me a hint? Of course, the carbon atom which will be attached to that of your two other carbon atoms, that will be called as a secondary carbon atom. And when a halogen is attached to such secondary carbon atom, it will be called as what? Your secondary alkyl halide. Examples: CRH and an X. Yes. So what is happening over here? If I consider my R could be your CH3 groups. So how it will be? CH3 H and an X. So whatever my halogen group is there, it is attached to the carbon atom which is further attached to two other carbon atoms. So when a carbon atom is attached to two other carbon atoms, such a carbon atom is called as what? Secondary carbon atom. So our secondary carbon atom again, our halogen is attached. So overall structure will be called as what? Secondary alkyl halide. Okay. The third important classification under your haloalkenes, it is called as your, yes, tertiary alkyl halide. Tertiary alkyl halide. So how can you write now this one? Yes. CR and an R. So what is this? Tertiary carbon atom. Why? Because it is further attached to three other carbon atoms. So to that tertiary carbon atom, whenever halogen is attached, it will be called as what? Tertiary alkyl halide. If I consider my R is equal to CH3 group, how can I write it? CH3 and an X. You can just see. So this carbon atom is further attached to three other carbon atoms. So that carbon will be called as what? Tertiary carbon atom. And to that halogen will be attached. The overall structure will be called as tertiary alkyl halide. Is that clear? So this was the first classification we have seen under the compound containing your sp3 CX bond. Alva. ಎಲ್ಲೇ ನೋಡ್ರು ಕೂಡ ನಮಗೆ ಸಿಂಗಲ್ ಬಾಂಡ್ಸ್ ಉಂಟು. ನಮ್ಮ halide ಯಾವ carbon ಗೆ attach ಆಗಿದೆಯೋ that will be attached to other carbon atoms through only single bond. So that is the reason now this C will be what? sp3 hybridized. Alva? That is the reason we have took this structures under the concept of your compound containing your sp3 CX bond. We are mainly concentrating on this bond. Okay. So this was one part under your compounds containing sp3CX bond. Coming to the another part, another classification itself, I can just say this was your first. Alkyl halides was your first. The second one is called as your allylic halides. Very much important to understand this one. Allylic halides. So before going with my allylic halides, let me make you sure what do you mean by allylic carbon. Another first in ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ ಅಲ್ವಾ, ಅವಾಗ ನಮ್ಗೆ ಈಸಿ ಆಗುತ್ತೆ. ಟರ್ಷರಿ ಆಲ್ಕಿಲೈಡ್ ಅಂತ ಯಾಕೆ ಹೇಳಿದ್ರೆ ಈಸಿ ಆಗಿದೆ, ಯಾವಾಗ ನಮ್ಗೆ ಟರ್ಷರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನು ಅಂತ ಗೊತ್ತಾದಾಗ ಈಸಿ ಆಯ್ತು. ಅದೇ ರೀತಿ ಅಲಿಲಿಕ್ ಹಲೈಡ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಗಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ನೋ ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಅಲಿಲಿಕ್ ಕಾರ್ಬನ್. ಲೆಟ್ ಅಸ್ ಗೋ ವಿತ್ ಇಟ್. ಓಕೆ, ರಿಮೆಂಬರ್ ಗೈಸ್, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ಯುವರ್ ಸ್ಟ್ರಕ್ಚರ್ so that it will be better understanding for you. Yes, CH2. Okay, let me write it in this way. CH2 double bond CH single bond CH3. Let me write it in this way. So this is an allylic carbon ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವುದು? this one is my allylic carbon. Can you see? So this is my allylic carbon. Can you please define it now? How can you define your allylic carbon? Yes, the carbon atom, yes, the carbon atom which is adjacent or which is next to, ಎರಡು ಬೇಕಾದ್ರೆ ಯೂಸ್ ಮಾಡಬಹುದು ಅಲ್ಲ, which is, I will just use my word as next to because it is easy. The carbon atom which is next to the carbon-carbon double bond. Able to understand? So what is allylic carbon? The carbon which is next to the carbon-carbon double bond. So that carbon is called as your allylic carbon. So ಆ ಒಂದು ಕಾರ್ಬನಿಗೆ to that carbon, if my halogen group is attached, in simple words, in case my halogen group is attached to my allylic carbon, it will be called as what? Your allylic halides. That is how can I write CH2 double bond CH single bond CH2 to this one my X. Yes, can I write in this way? So this is an example of your allylic halide. So how can I define now my allylic halide? Compound. Yes, this is my compound. Alva. Compound in which halogen, yes, compound in which the halogen is bonded to sp3 hybridized. Alva. This carbon is sp3 only. These two are what? sp2. Idiya sp3 ne idu. Alva. So compound in which the halogen group is bonded to the sp3 hybridized carbon atom which is next to. Alva. So this carbon atom is next to carbon-carbon double bond. So these are called as your allylic halides. So why it is coming under this concept, compound containing sp3CX bond? Because whatever our halogen is attached, though it is allylic carbon, but what is its hybridization? It is sp3 hybridized. So how can you define an allylic halide? A compound in which your halogen group is attached to the sp3 hybridized carbon atom, which is, this is important, next to your carbon-carbon double bond. So they are called as your allylic halides. What do you mean by allylic carbon? The carbon which is next to the carbon-carbon double bond. So they are called as your allylic carbon. Yes? Okay. This was another classification. Coming to a third classification under this concept, there is compound containing your sp3CX bond. How can I write it? Yes, that is called as your benzylic halides. Benzylic halides. So basically I would like to give one more example over here in my allylic this one. halides. Yeah, this could be also your allylic halides. How can I write in this way? Yeah. See, ಈಗ ಎಲ್ಲಿರಬೇಕು ನನ್ನ ಎಕ್ಸ್ ಇಲ್ಲಿ ಇರ್ಬೋದಲ್ವಾ? ಅವಾಗ ಏನಾಯ್ತು, this is C ಅಲ್ವಾ? this is C is what? This is now sp3 hybridized, which is next to ಅಲ್ವಾ? So this you can write, it will be clear for you. So E1 to C, this is now what? sp3 hybridized. This is an allylic carbon. Why? Because it is next to your CC double bond. So this is also coming under the concept of your allylic halides. So allylic halides, one important thing should get printed in your brain. What is that? Whatever our halogen group is there that has been attached to our allylic carbon. What do you mean by allylic carbon? The carbon which is adjacent to that of your CC double bond. Is that clear? Coming to the third important classification under the concept of your compound containing sp3CX bond, it is called as your benzylic halides. What it is? Benzylic halides. So let me give you an example over here. So yaduna now benzylic halides anta heltivi. Of course, two hints we are having. One is what? Benzylic one, and second most important thing, it is coming under your sp3CX bond. ನಮ್ಗೇನ್ ಗೊತ್ತು, ಬೆನ್ಝೀನ್ ಅಲ್ಲಿ ಅಫ್ ಕೋರ್ಸ್ ಎಲ್ಲ ಬಾಂಡ್ ಡಬಲ್ ಬಾಂಡ್. ಸೊ ಆಲ್ ದಿ ಗ್ರೂಪ್ಸ್ ಆರ್ sp2. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿಗ sp3 ಎಲ್ಲಿ ಬರುತ್ತೆ? ಅಫ್ ಕೋರ್ಸ್ ಅಲ್ಲ, ಇಲ್ಲಿಂದ ಒಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಇರಲೇಬೇಕು. ಸೊ ದಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ವಿಲ್ ಬಿ ವಾಟ್? ಎಸ್, it should be, this carbon should be now a saturated carbon atom which is sp3 hybridized. Since it is falling under the halides, ಏನಾಗಿರುತ್ತೆ, ಇಲ್ಲಿಗೀಗ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ. Is that okay? So what do you mean by now benzylic halides? First you have to understand, benzylic halides is coming under the concept of your compounds containing your sp3CX bond. So benzylic benzene will be there. Of course, it's an aromatic ring will be there. Aromatic ring means it has to follow the Huckel's rule, 4n+2 rule. Of course, the carbon atoms will be unsaturated. So in that unsaturated, where can we get a saturated carbon? Of course, we need a one more substituent. That is this substituent. So this substituent's carbon, what it will be? sp3 hybridized. So whenever halogen is attached to such sp3 hybridized carbon, which is next to our aromatic ring, alva, once again I am repeating, the compound in which the halogen group is attached to the sp3 hybridized carbon, which is next to our aromatic ring. So this is called as what? Your aromatic ring. So such structures or such compounds are called as what? Your benzylic halides. Compounds in which your halogen is bonded to your sp3 hybridized carbon, which is next to your benzene or your aromatic ring. Let me be particular. It is called as what? Next to your aromatic ring. So those structures will be called as your benzylic halides. Yes. So let me go with another example over you. So this is my aromatic ring. Yes. Of course, what I'm going to do is I will take it as here also as an R, or let me be specific of my, let it be here as a CH3, here as a CH3, and here as my X. So of course now this will be also called as your benzylic halides. Why? Because whatever my halogen group is there or halogen atom is there, that has been attached to the carbon atom which is next to my aromatic ring. So these are also called as your benzylic carbon, also they can be called as. But you have to remember, what do you mean by this benzylic halides? So why it is coming under the compounds containing sp3CX bond? Because whatever our X group is there, that's your halogen group is there, it has been attached to your sp3 hybridized carbon atom. So important classification, what did we see? Of course, the compounds containing sp3CX bond, first we saw of your alkyl halides or haloalkanes, in which what we saw, major thing, our halogen group will be attached to that of your alkyl groups. Alva. So there we saw your primary alkyl halide, that is your halogen group is attached to that of your primary carbon atom. In a secondary alkyl halide, the halogen group is attached to that of a secondary carbon atom. Tertiary alkyl halide, the halogen group is attached to that of your tertiary carbon atom. What do you mean by primary carbon atom? The carbon atom which has been attached to one carbon atom, they are called as a primary carbon atom. Remember, there is also a case which is this carbon is also called as a primary carbon atom. That is, it will be directly attached to that of only hydrogens. Yes, so this is also an example of your primary carbon atom itself. Coming to that of your secondary alkyl halide, the carbon atom which is attached to that of your two other carbon atoms, they are called as what? Secondary carbon atom. Tertiary, the carbon atom which is attached to three other carbon atoms, they are called as your tertiary carbon atom. Coming to the next classification, we saw it was your allylic halides. So what do you mean by allylic halides? In a compound, if the halogen group is attached to that of your sp3 hybridized carbon atom, which is next to the CC double bond, such halides are called as your allylic halides. Yes. Coming to that of your benzylic halides, we saw the halogen group is attached to the sp3 hybridized carbon atom, which is next to that of your aromatic ring. Please do remember, don't write benzene ring, write it as aromatic ring itself, because we will be seeing many such aromatic structures are there. That is the reason. Since it was easy and convenient for us to know what is this aromatic, we know it is a benzene, so I have chosen this as an example. So whenever you are writing the definition for an benzylic halides, please use the word as aromatic ring. Don't use as a benzene ring. Okay. So this was whatever the three important sub-classifications we have seen. It is coming under the main classification of compound containing sp3CX bond. Of course, now the doubt arises, sir, is there another classification? Of course it is. So that classification will be called as compounds containing your sp2CX bond. sp2CX bond. I hope you are all getting a hint. sp2 means what? Of course, whatever our X will be attached, it will be attached to that of your sp2 hybridized carbon atom. sp2 hybridized, when it will be called as, when it is having, then that carbon atom is a doubly bonded to that of your another carbon atom. Alright. The double bonded carbon atoms will be called as what? Your sp2 hybridized carbon atom. So under this, the first important sub-classification we'll be seeing, which is called as your vinylic halides or vinylic halides. So allylic mein what we saw, of course the halogen group is attached to the carbon atom which is adjacent to the double bonded carbon atom. Why? Because it was we wanted sp3 hybridized. But here what is happening? Of course we need sp2 itself. Yes. How can you write it now? CH2 double bond CH single bond X. Can I write it in this way? Yes or no? You should only help me. So what is happening over here? Halogen group is attached to that of your sp2 hybridized carbon atom. Alva. So the compound in which your halogen atom is bonded to, or you can say bonded directly to that of your sp2 hybridized carbon atom of a carbon-carbon double bond. Carbon-carbon double bond. So these are called as your vinylic halides. Don't get confused with allylic and vinylic. Allylic mein A is the first alphabet. So A means first you have to see sp3 mein aata. Then go with your vinylic, in which it is attached directly to sp2 hybridized carbon atom. Similarly, in case if I'm going to write over here where I should write my halide, yes. So these are my double bonded carbon atoms. Directly I could write over here. Yes or no? So these are the examples for your vinylic halides, in which your halogen group is attached directly to sp2 hybridized carbon atom of a carbon-carbon double bond. Coming with respect to vinylic halide, there's another important sub-classification which is called as your aryl halides. What it is called as? Your aryl halides. So aryl halides may, of course, in benzylic what we saw, a slight change in it. So in benzylic we saw it is attached to an sp3 hybridized carbon atom which is next to your benzene, also your aromatic ring. So here what is happening? Yes, it will be directly attached to that of your aromatic ring in this way. Yes. So this could be called as what? Your aryl halides. So how can I define it? The compound in which your halogen atom is bonded to your sp2 hybridized carbon atom of an aromatic ring. Directly attached to the top of your aromatic ring. That halides structure will be called as your aryl halides. Similarly, if a substituent is also there, you can write it in this way also, CH3 will be there. So this is also the important. But basically what we are seeing, the CX bond. This is giving our important classification. So if the CX bond ka C is sp3 hybridized, the first classification we have to go. If the CX bond ka C is sp2 hybridized, the second classification we have to go. So in the second classification, we saw vinylic halides in which your halogen atom is directly bonded to the top of your vinyl carbon. That is the carbon atom which is doubly bonded. Yes. In aryl halides, we saw the halogen atom is directly bonded to the top of your aromatic ring. So next, we are going to see certain important nomenclature of your haloalkanes and haloarenes. So guys, soon after we have seen the classification of your haloalkanes and the haloarenes, the most important thing we have to learn is how to name those compounds. So basically, whenever we are going with the naming, of course we know that our naming has been divided into two important types. One is known as that of your common name. That is when the structures were identified for the first time, what is the name that they have given to that structures. And then is our International Union of Pure and Applied Chemistry, IUPAC nomenclature. Of course, the IUPAC system is very much worthy to understand, but also it is also that much itself important to know the common name of certain structures. So let us begin with the nomenclature of your haloalkanes and haloarenes. Basically, let me first of all introduce how to give the common name for your haloalkanes. Yes. Basically, whenever you are naming your haloalkanes, do remember that is also in a common name. First of all, we have to write the respective alkyl group, and then we have to add it their respective halides. For example, if I am giving you the structure as CH3, CH2, CH2, Br. So what is the alkyl group over here? Of course, this is my alkyl group. So what is the general structure I will be calling them? If in case it was CH3, CH2, CH3, I would be calling it as an N-propane. But since one hydrogen I am removing out, what will be called as N-propyl. N means what over here? Normal. Normal propyl. Okay, my alkyl group I have named it. Now I have to add it as an halide. What is the halide over here? As a bromide. So what will be my common name for the structure? N-propyl bromide. Alva. Normal propyl bromide. Similarly, if I am going to write it as CH3, CH3, here is my Cl. Of course, what is the structure? Basically, it is normally it is isopropane. Yes, but since one hydrogen is missing, isopropyl. So I have named my alkyl group isopropyl. Halide is your chloride. So isopropyl chloride. Similarly, CH3, CH, CH3, CH2, Cl. Yes, it is what type? 1, 2, 3, 4. Yes, iso. Yes, butyl. Alva isobutane ಆಗ್ತೈತೆ ಯಾವಾಗ CH3 CH3 CH CH3 ಇದ್ರೆ. But since one hydrogen is missing, so isobutyl chloride. So this is the way of writing your common name for your haloalkanes. First you have to mention their respective alkyl group, and then you have to add their respective halides. Alva. So this was with respect to your common name. Of course, the IUPAC name we can write it easily. Alva. First and the foremost thing, we know that in the IUPAC name you have to select a parent chain which is long as possible and containing maximum number of your carbon atoms. Second most important thing, you have to number the carbon atoms. Repeat once again, you have to just number the carbon atoms. Numbering is very much important because it depends where your substituent groups are present. So if I'm taking my first part, of course, I have to number the carbon atom where my substituent is present. Of course, it is present in the last end, so my numbering starts from here, because the carbon atom containing or it is attached to the substituent, that carbon atom should get the least number. So 1, 2, 3. So how can I write it? Yes, 1 bromo. How many carbon atoms? 1, 2, 3. So 1 bromo prop. The bonding is single, so ane. So 1 bromopropane. What is the 1 signifies over here? To which carbon our substituent is added. Bromo indicates that what is our substituent. Prop indicates the number of the carbon atoms. Ane indicates the homologous series, that it is belonging to an alkane group. Yes? Can you please help me with the second? Okay. So I can number in either way. Salva, here also I can number as 1, 2, 3. Or also I can number as 1, 2, 3. In both the cases, the carbon to which your substituent group is attached is getting the least number, that is the same number itself. So how can I name it? First, yes, 2 chloro. I have named my substituent. Then number of the carbon atoms 1, 2, 3. So prop, homologous series is an alkane, so 2 chloropropane. This one, so basically you just remember here we are having 2 substituents. So of course, first my chain I have to select. So this is my chain, longest chain, parent chain. So how can I number 1, 2, 3? Yes, this is the one way. And I have to remember that there are 2 substituents present over here. Whenever the 2 substituents are present, what should be a protocol? The addition of the number of the 2 substituents should be lowest number. So in this case, of course, if I am going to number in this way or in this way, where is the possibility? Of course, the substituent should get the lowest number. So 1 chloro, yes, 2 methyl, yes, no space, it is called as your 3 carbon atoms, parent chain the more carbon atoms. So 1, 2, 3. So 1 chloro, 2 methyl prop ane, alva. If I am writing in this way, 1 chloro, then hyphen 2, which indicates your second substituent, that is which one? Methyl, yes. Then comes your propane. This is the way of your writing. So first is the first substituent is 1 chloro. Why chosen my chloro as itself is the first? Alphabetical rule. C comes first, then comes your M. Alva. So that is the reason 1 chloro. In case if it was something else, means I should have seen what is the alphabet we are getting as a substituent. Since here chloro is having the C and then the second is having M, of course in the alphabetical order C comes first. So 1 chloro, 2 methyl propane. So this is the funda for your naming of your haloalkanes. But when it comes with respect to that of your haloarenes, how will you name it? Of course, whenever we are naming your haloarenes, remember we are mentioning directly it as an aryl halides. Aryl halides, the respective aryl halides. For example, if I am going to choose as this one. So here is my Br. So their common name would be what? Yes, of course, bromobenzene. Alva, bromobenzene. So bromine is attached to of your benzene ring. So directly we can write it as a bromobenzene. But the question arises that when we are having the 2 groups present, for example, here is my group Br and here is one more group as a Br. So how can I name it? Of course, in my common name, I would be using the prefixes, that is your ortho, meta and para. So how can I mention which is this position? Remember, with respect to this group, this is my ortho position, this is my meta position, this is my para position. So what will be the name of this compound? Yes, meta, which will be represented just by small letter m. M means meta with respect to this position. So meta dibromobenzene. Meta dibromobenzene. So remember, once again I am saying with respect to the first group, with consideration of this group, I am saying that it is in the meta position. But in case if my structure was in this way, that is, here was my Br and here was my Br, of course here also what happens? With respect to this group, this is now ortho, this is now meta, ortho, meta, and this will be my para. So both will be having your meta dibromobenzene itself. Why I am saying? Because you don't get confused that this is meta antalla. With respect to first this group, we are saying this is meta. Similarly over here, with respect to this group, this position will be meta. Is that clear? So it is called as what? Meta dibromobenzene. So in case if I am having in 1, 3, 5 position, if I take it as a Br and Br way, remember, so it will be called as a symmetric SYM tribromobenzene. Tribromobenzene. So this is a common name. But let me ask you a question, since we have dealt with this now. If my position is over here and over here, what will be it called as? With respect to this bromine, so this is your ortho position. So how can I write? Ortho, O dibromobenzene. Dibromobenzene. So in case if I am going to write my Br over here and one more Br over here, so what will be named? It will be called as, with respect to now this position, now this is your ortho, meta, and this will be your para. So how will you write that? So para dibromobenzene. Why am I saying? Because the group which you take as for your consideration, the next position will be your ortho. Okay, this ortho, meta, and para only comes when you are having the di substituents. Okay, now one the substituent consider Madi, we will be saying which is your ortho, which is your meta, and which is your para. Now if I am going to write their IUPAC name, for example, the first example I choose was my bromobenzene. Remember, very much interesting. Here the IUPAC name is also your bromobenzene itself. Common name and IUPAC name both are same in this case. But when the question arises with respect to your di-substituted haloarenes, slightly varies. So if here is my Br, here is my Br. Remember, I had to number it. So this will be my first position. This is my second. This is my third. So how can I name it? 1, 3 dibromobenzene. Dibromobenzene. Remember, this was called as by the common name as what? Meta dibromobenzene. The 1, 3 position is always called as your meta position. For that reason, if I am going to choose the example, so I have chosen over here, I hope, yeah, Br, and you are having, yes, over here. Of course, now this will be my first position, this will be my second, this will be my third. So I will be getting the same name as the 1, 3 dibromobenzene, that is your meta dibromobenzene. Why I given this example? Because you can see the number. With respect to my first position, I am getting this one as my third number. So with respect to the first position, the group will be in the meta position. Is that okay? So this is the thing you have to remember. So 1, 3 position will be called as that of your meta dibromobenzene. So if I take my symmetric tribromobenzene, can you please number it? Yes, this will be my 1, 2, 3, 4, and 5. So what it can be called as? Yes. So let me write it over here. 1, 3, 5. Alva? 1, 3, and 5. Then hyphen tribromobenzene. Tribromobenzene. So this is your IUPAC name. Can you see how we have written? So first, IUPAC and common name both are same, bromobenzene. When you're coming with the di-substituent, you have to number it. So 1, 3 position is your meta position. So what will be your ortho position? Of course, 1, 2. 1, 2 will be ortho position. 1, 3 will be a meta. 1, 4 will be a para position. Very much important to know these things. Let me give now one simple examples for you. So I have a structure over here in this way. Let us solve certain nomenclatures. Sometimes they can give you in this, so there should be a way of writing it. So this is my CH3, here is my H, here is my H, here is my in this way Cl. So CH3 and over here as H. Let me take it in this way, this structure. Looking like a complex, but it's very much simple. So whatever they have written is a bond representation. Yes, each and every intersection. So here only one intersection. Basically it should come in this way. Yeah, like this. So in this way. So like this. One intersection. Each intersection means one carbon atom. So if I'm going to write it in a proper way, so it will be in this way: CH3, H, double bond C, H. Of course, here also one carbon, and here I'm having as a H, Cl, and a CH3. So if I'm going to write it in a proper way, how can I write it? Yes, of course, CH3. First I have written this part. Single bond, this carbon, which is also having a H, yes, CH. Then I am having my double bond, yes. So then I am having my CH, yes. So to that C, one more C is attached. Okay. CH, yes. Then I am having CH3. But to this carbon I have also attached my chlorine. Yes. So now the question arises how you are going to name it. Alva, very much important. So first and the foremost thing, the first preference is to our double bond. So this double bond should get what? Lowest number. Then we have to give the preference for our substituents. So how can I write it? This is my first, second, third, fourth, and my last part is your fifth. Priority prakara. First priority is for a double bond. Then is for our substituent. So while naming, of course, what you have to name first? The substituent part you have to name first. Prefix na first name madbekalva. So yavtara, that is your fourth positional untu. Yes. Then we have to name it as chloro, the substituent for chloro. And then you have to mention your root word. You know the root word, how many number of carbon atoms? So 1, 2, 3, 4, 5. Yes. So pent. Okay, root word is over. Then what do you remember? Yes, the suffix part. Primary suffix. What is that? Yes, please. The homologous series. So it is having what over here? Pent. Second position mein you are having your E. So 4-chloro-pent-2-ene. So whenever you are having such a complex structure, try to reduce it in a simple structure. Let us go with one more example. So double bond you are having. Let me give it over here as this way. CH3 and over here as Cl. Over here as CH3 and over here as H. Here as a H. Here as H. So how can I name it? Remember, each and every intersection contains one carbon. Let me write it directly for you. So in this way, CH2 double bond. Yes. Then this C. Okay. Which is having one CH3 over here. See? E CH3 ಮೇಲೆ ಬರ್ಕೋಬೇಕು ಯಾಕೆ ಇದಕ್ಕೆ ಯಾವ ತರ ಬಾಂಡ್ ಕೊಡೋಂಗಿಲ್ಲ 4 ವೇಲೆನ್ಸಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಿದೆ ಆದರೆ ಇಲ್ಲಿಗೆ ನಾನು ಬೇಕಾದ್ರೆ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಬರ್ಕೋಬಹುದು ಯಾಕೆ ಬಿಕಾಸ್ ಇಟ್ is having 4 atoms in this way. C, in which one is your Cl, of course one is your H, another is your CH3. So in this way. So how are you going to number it? Of course the first priority to this one. So first, second, third, fourth. ಯಾವತ್ತಾಗಲಿ ಫಸ್ಟ್ ಯಾವುದು ನಾವು ನೇಮ್ ಮಾಡಬೇಕು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ನ ನೇಮ್ ಮಾಡಬೇಕು ಬಟ್ ಡೂ ರಿಮೆಂಬರ್ ಹಿಯರ್ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಸೊ ಈ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಇದ್ದಾಗ ಏನ್ ಮಾಡಬೇಕು ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್ ಯಾವ ಫಸ್ಟ್ ಆಲ್ಫಾಬೆಟ್ ಬರುತ್ತೋ ಅದನ್ನ ಫಸ್ಟ್ ಬರ್ಕೋಬಹುದು ಡೋಂಟ್ ಸಿ ದಿ ನಂಬರ್ ಡೋಂಟ್ ಗೋ ವಿತ್ ದಿ ನಂಬರ್ ಆಲ್ಫಾಬೆಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಆ ರೀಸನ್ ಇದೆ ಏನ್ ಬರ್ಕೋಬಹುದು ಇದು ಕ್ಲೋರೋ ಇದು ಮಿಥೈಲ್ ಸೊ ಸಿ ಕಮ್ಸ್ ಫಸ್ಟ್ ಬಟ್ ನಂಬರ್ ಯು ಸಿ ಇಟ್ ಇಸ್ 3 chloro then hyphen 2 methyl. Alva, can you see the difference? Of course, now it is 3, it is 2, but we are not considering their number, instead we are considering their alphabets. C comes first, then comes your M. Then what you have to write, once we have done with our prefix, then you have to go with your root word. What is that root word? Number of carbon atoms. 1, 2, 3, 4, which means what? But. Then you have to give your primary suffix, that is what type of bond it is having. But, the second position I am having my ene. Sorry, not the second, first position. But 1 ene. Alva. Here also we did the same thing. The first part we had to check. E carbon atomic join. You can numbering now ಮಾಡಿರೋದು E ರೀತಿ. So we are going in this way. Here also we have gone in this way. So first position onto your E. Is that clear? Okay. Now let us take one more. Let me take over here as my CH3 and over here as my H. Double bond. We take it over as a CH3 and over here as my Cl, here as my H, and here as my CH3. Can you please do it? Of course we can do it. First let me write my this C. Yes, to this one have been attached with CH3. Okay, this has been complete. E C on H kuda untu. Okay. Ade C on the double bond untu. Yes. Then this C. Okay. To that one I am having one CH3. Okay. Then it is once again attached to one more C, which is having your Cl, which is having an H, which is having your CH3. Number it. 1, 2, 3, 4, and a 5. Yes. So how will you number it? First yaad baritirega alphabetical order prakara. Yes. The 4 chloro. 4 chloro. 4 hyphen chloro hyphen. Then 3 methyl. Alva, because according to your alphabetical rule. Then afterwards root word pent. Then comes your hyphen 2 hyphen ene. Is that okay? So now by seeing these structures, one important thing again and again I remind you how to remember your nomenclature. Alva, yav ತರ ಒಂದು ಹೆಸರನ್ನು ನಾವು ಯಾವ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರಿಬೇಕು ಅಂತ. I mentioned it many times, but once again it's my duty to mention you. Remember, first we have to write your prefix. Prefix andre enu? Any substituent idre. Of course, in the case now nodiddivi aduna. Substituent means what one? This is your methyl, this is your chloro. Parent chain na ಹೊರತುಪಡಿಸಿ ಯಾವುದೇ ಗ್ರೂಪ್ ಇದ್ರೆ ಅದೇನಾಗಿರುತ್ತೆ ನಿಮ್ಮ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಆಗಿದೆ. ಸೊ ಯಾವತ್ತೇ ಫಸ್ಟ್ ನಾವು ಏನು ಬರೀಬೇಕು? ರೆಸ್ಪೆಕ್ಟಿವ್ ನಂಬರ್ ಇನ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಬರೀಬೇಕು. Once you have written the prefix, then you have seen we have written what? The number of the carbon atoms, which is called as what? Root word. Alva, which indicates what? What is the number of the carbon atoms? 1, 2, 3, meth, eth, pro, pent, atara barita, but, alva, number of carbon atoms. So here we see, first our was prefix. Illi varig nam prefix bantu. First we have written our respective what substituent groups. Then we have remembered our carbon atoms. How many numbers were there in the parent chain? 1, 2, 3, 4, 5. So number of the carbon atoms 5 idre. What is the root word we are going to use? Pent. Soon after you have written your root word, then the next part is that of your primary suffix. So you know the suffix, primary suffix indicates your saturation or unsaturation. Alkano, alkeno, ಅಥವಾ alkyno ಅಲ್ವಾ. ರೂಟ್ ವರ್ಡ್ ಆದ್ಮೇಲೆ ನಾವು ನೆಕ್ಸ್ಟ್ ಏನು ಬರ್ದ್ವಿ? ನಮ್ಮ primary suffix along with its position idre position barkobeku. 2 ene. So this represents your alkene homologous series. So primary suffix indicates your respective homologous series. So saturation or unsaturation antanu heltivi. Saturation or unsaturation. Of course the second part will be a secondary suffix. In this case it is not necessary because it indicates your functional group. Of course in our structures we are not having any functional group, so we are not writing this. So each and every structure you can just see. First we have written our prefix. Prefixal kuda primary and secondary is there, but just for a while, in order not to confuse you, I'm just saying one prefix. So first the prefix indicates your substituents. Yes. And then is that of your root word, indicates your number of the carbon atoms. and then is our primary suffix, which indicates our saturation or unsaturation. You can see any of the examples we have given till now, they all contains the same scenario. First you have to write the prefix, which indicates your substituent. Then you have to understand what is the number of the carbon atoms, which is indicated by root word. Then through primary suffix, which indicates your saturation or unsaturation. Then your secondary suffix, which indicates your functional group. So this is the protocol of writing your structure name, IUPAC name for your organic compounds. Is that clear? So let me go with now by having this knowledge. Now let us take one more thing of an example. Simple example. Let me take it CH3, CH, CH, CH2, CH3. Yes. So let it be Cl, let it be over here as CH3. So can you please help me now? Okay, let me first number it. In the number first no rule for me is the carbon atom containing the substituent should get the least number. In case if I am going to number from here 1, 2, 3, 4, 5. So when I put there the sum tagondaga. So let me write it over 1, 2, 3, 4, 5. So 4 plus 3, which is equals to 7. Not possible. Okay, this is one possibility. One more possibility is 1, 2, 3, 4 and 5. Second possibility. So in other 2 plus 3, which means equals to 5. So sum if you are having the two substituent and you're taking those sum of those numbers of the substituent, if you're getting the least number, that numbering should be taken into consideration. So that is the reason which one I am going to choose this part. 1, 2, 3, 4, 5. Is that okay? Numbering ಮಾಡಿ either ways ಯಾವುದು ಪಾಸಿಬಿಲಿಟೀಸ್ ಇರುತ್ತೋ ಅದನ್ನ ಸಮ್ ಮಾಡಿ. ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಮೋರ್ ದನ್ ಒನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಸಮ್ ಮಾಡಿದಾಗ ಯಾವ್ದು ಲೀಸ್ಟ್ ಸಮ್ ಬರುತ್ತೋ ಆ ನಂಬರಿಂಗ್ ಸಿಸ್ಟಮ್ ನ ನೀವು ಅಳವಡಿಸ್ಕೋಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಕನ್ಸಿಡರ್ ದಟ್ ನಂಬರಿಂಗ್ ಸಿಸ್ಟಮ್. ಸೊ ಸಿನ್ಸ್ ಐ ಹ್ಯಾವ್ ಗಾಟ್ ಮೈ 2 plus 3 is equals to 5, so this is my numbering system. So now of course first what I have to write? I have to write my prefix, which indicates what? Our substituent. So ಇಲ್ಲಿ substituent ಯಾವುದು ಈಗ Cl and CH3 two substituents are present. So two substituents I have to write it in a alphabetical order. ಇದು ಕ್ಲೋರೋ ಅಂದ್ರೆ C, ಮಿಥೈಲ್ ಅಂದ್ರೆ M. ಆಲ್ಫಾಬೆಟ್ ಪ್ರಕಾರ A B C. First comes our C. Position ಜೊತೆ ಬರ್ಕೊಂಡಲ್ವಾ 2 hyphen chloro 1 over. Then hyphen 3 methyl. Yes. So I have gone with my prefix part. So next is what? My root word, which indicates what? The number of the carbon atoms. So the number of the carbon atoms of my parent chain idalva, the longest chain rule. Yes. What is the number of the carbon atoms? 1, 2, 3, 4, 5. Yes. 5 andre root word. Very good. Pent. Next. Root word is over. Then I have to go with my primary suffix, which indicates my saturation, unsaturation. Alkano, alkeno, alkyno. Of course, ನನ್ನ parent chain ಅಲ್ಲಿ ಇರೋದೆಲ್ಲದು single bond. So of course it belongs to what? Alkene. So alkene ಗೆ ಏನು ಯೂಸ್ ಮಾಡಬೇಕು ನಾನು? ANE. Yes or no? So 2 chloro 3 methyl pentene. Secondary suffix ಅಲ್ಲಿ functional group ಉಂಟು. ನನ್ನ structural functional group ಇಲ್ಲ. So eliminated. That is the common protocol of writing your structures. Is that clear? Okay. Let me give you one more example. In case this is your structure, what you're going to write it? Of course, this is the only structure. This is called as your cyclohexane because it is a cyclic ring. So it is called as what? Cyclohexane. But to this structure, if I am going to add my Cl, what are you going to write? Of course, what are you going to write? Chlorocyclohexane. Yes. Similarly, if I am going to write over here as C2H5, let me take it in this way. So then now the question arises. So this is my preference. 1, 2, 3, 4. So the IUPAC name will be 1 hyphen chloro. Yes. Then hyphen 4. What is this? If I'm going to write it as C2H6 means I know it is ethane. If I'm going to take out one hydrogen from it, yes, it becomes your ethyl. So same thing. So now this will be called as what? Ethyl. So 1-chloro-4 ethyl cyclohexane. Cyclohexane. Very much important. ಇಲ್ಲಿ ನಾ ಹೇಳಿದಲ್ಲ ಪ್ರೆಫಿಕ್ಸ್ ಅಂತ, ಅದೇ ಪ್ರೆಫಿಕ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ, ಒಂದು ಪ್ರೈಮರಿ ಇನ್ನೊಂದು ಸೆಕೆಂಡರಿ ಪ್ರೆಫಿಕ್ಸ್ ಅಂತ ಬರುತ್ತೆ. Primary prefix indicates your secondary, so your substituent. Secondary prefix indicates this word called as your cyclo. So primary prefix ಅಲ್ಲಿ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಯ್ತು, substituent present. Cyclo ನಮ್ದು ಏನಾಗುತ್ತೆ, secondary prefix ಆಗಿರುತ್ತೆ, indicating your ring structure. ಯಾವ ತರದ ring, secondary prefix. Then comes your root word, which is that root word 6 carbon atoms alva, 1 2 3 4 5 6, indicating 6. Then comes your primary suffix. Do remember here it is called as a primary prefix. Pre anta bartha, previous age pre anta baruttalla, prefix previous age add agta untu. Illen bartha untu. Then you are having ane, which is indicating your primary suffix, which comes after. Is that clear? Just for having a knowledge of it, I have just given this example. But most important thing, whenever we are dealing with this haloalkanes and haloarenes nomenclature, we will be seeing a common name which will be arising again and again in your competitive exams many of the times, which is called as that of your gem halides and called as your vicinal halides. Very much important to know their structure and when they are called so. Basically, these are coming under your haloalkanes and haloarenes itself, because we are having a hint that it is and having an halogen over it. But how the structure looks. Remember, in gem halides, what is happening means you are having the halogen atoms. Basically, if I'm going to take as a 2 halogen atoms, so both the halogen atoms will be present. Halogen atoms will be present on the same carbon atom. Generally, we'll be seeing your structure called as a gem dihalides anta ಹೇಳ್ತೀವಿ. 2 halogens iddaga dihalides. How this structure will be means, if I'm going to write CH3 CHCl2. So if I'm going to write a bond representation, how can I write it? H CH Cl and Cl. You can just see that both the halogen atoms are attached on the same carbon atom. So like this structures are called as what? Your gem dihalides. Wow, gem dihalides. Then what is about your vicinal dihalides? Somewhat slight modification. I hope you can only guess. What is your guess? Let me ask you first. I will be giving you the 3 seconds. Gem alli 2 halogen ಒಂದೇ carbon atom ಮೇಲೆ ಇತ್ತು. Vicinal dihalides ಕೇಳ್ತೀನಿ, ಏನಾಗಿರುತ್ತೆ? Yes, any hint? Or you can give me an answer. Yes, the 2 halogen atoms will be present on the 2 different carbon atoms. That also on the adjacent carbon atoms. ಯಾವ ತರ? For example, if I'm going to write it in this way, CH2 and CH2, basically here one halogen, here one halogen. So the 2 halogens are present on the adjacent carbon atom. Remember, very much important. Adjacent alle ಆ 2 halogens ಇದ್ರೆ, so they are called as what? Your vicinal dihalides. Very much important to know these terms. So basically, in common name, of course, whatever we have seen, this was nearly, now also we are using in an IUPAC nomenclature, although sometimes we use it, but generally they were given as a common name. So gem dihalides, very much important, guys, to remember this common name also, because certain times in competitive exams they have asked it. This gem dihalides is called as your alkylidene. Very much confusing words. Alkylidene halides. Common name. Keda chances irutte. What is the common name for your gem dihalides? It is called as what? Alkylidene halides. But in vicinal, a slight modification which is called as alkylene itself. Alkylene. ಇಲ್ಲಿ ಏನಾಗ್ತಂತು ಡೀನ್ ಅಂತ ಶಬ್ದ ಬರುತ್ತೆ, ಇಲ್ಲಿ ಏನ್ ಬರ್ತಾ ಉಂಟು ಓನ್ಲಿ ಈನ್ ಅಂತ ಶಬ್ದ ಬರುತ್ತೆ. ಸೊ alkylene halides, very much important. So first and the foremost thing, you have to understand what do you mean by gem dihalides and vicinal dihalides. Gem dihalides means the halogen atoms are present on the same carbon atom, whereas vicinal dihalides means the halogen atoms are present on the adjacent carbon atoms, on the adjacent, yes, carbon atoms. Alva, very much important. So this is called as your gem dihalides, these are called your vicinal dihalides. But when we are coming to respective common names, the gem dihalides is also called by the common name as alkylene halides, whereas that of your vicinal dihalides is called as what? Alkaline. Alkaline halides. Ili alkylidene, ili alkaline. Okay, very much important to remember these things. But in case if I am going to, just for your part, how much you have learned so far, if I am going to write my proper IUPAC name for this structure, can you please help me out how to write it? So what will be the name of this structure? Yes, numbering. Of course, this is my first position, this is my second position. Very much carefully you have to answer this question. So this is my structure, how will you name it? First, what you have to write? Prefix, that is your substituents. How many substituents? 2 substituents, alva. Of course, both the substituents are same, but how many are there? 2 are there. So you have to also indicate the number. Yes, sari barta untu yava position untu anta nama structure indicate ಮಾಡಬೇಕು. How will you indicate it? In my indication, I have to say that, okay, in that carbon atom, the chlorine groups are present twice. So how will you rhyme it? First, alva, 1. But another group is also chlorine. How will I name it? 1,1 itself. Because 2 times they are present on the same carbon atom. So 1,1. Then comes dichloro. Alva, because indicates your how many numbers of your chlorine groups are present. Dichloro. So this indicates my prefix. Next is your root word. How many number of carbon atoms? 1, 2. So 1,1 dichloroeth. Then indicates your primary suffix. That is your saturation or unsaturation. Single bond. So ane. So 1,1 dichloroethane is called as your gem dihalides. Sometimes they can ask you, give the IUPAC name of your gem dihalides. What is this called as? 1,1 dichloroethane. Help me out in writing my vicinal dihalides. CH2, CH2, Cl, Cl. Of course, 1, 2. 2 are the same, but they are present on the different positions. So how can I write it? Of course, 1 chloro. Sorry, 1, not 1 chloro. 1, 2. Because they are present on this same groups are present, but positions are different. So 1, 2 hyphen, how many numbers? 2 are present, so 2 are represented by what? Dichloro, yes, ethane. So 1, 2 dichloroethane will be called as your vicinal dihalide. So these are the way of writing your nomenclature of your respective haloalkanes and haloarenes. So in our next video, we'll be going to see nature of your CX bond.